Session 1.1 Statistical and Critical Thinking. First, why do we need to study statistics? Not only fulfill your requirement, right? We want to study the statistic because there's some reason behind. First, effectively conduct research. We need to know how to conduct the research, and it is very important for today's work. Second, make the decision based on the data collected from the research project. Let's say you guys go to the university or you go for the business field. Sometimes you want to do the research project and you need to make the decision based on the data. After you collect the data, you have to know what the data means and you need to know how to interpret it and conclusion. Able to read the journals, since most journals contain some form of statistic. So when you guys read the journals, there's some terms for the statistic like the mean, the standard deviation, variance. You need to know what is the meaning of those statistic words and you need to know the reason in behind it. And also develop critical and analytical thinking. So when we conduct a statistical study, this process consists of prepare, analysis, and conclusion. So the first one we're going to talk about is going to be the preparation. Okay, the preparation involves consideration of the context, the source of the data, and also the sampling method. So first one, we're going to talk about the context. What do the data mean and what is the goal of the study? So for example, if I have some data, measure IQ score and measure the Bing volume. So the data is related to the IQ score and also the Bing volume. So first, you need to set the goal. What is your goal of this data? I could set my goal like determine whether there is a relationship between IQ score and brain volume. Okay, I want to know if I have higher IQ score, will my brain will be bigger than the normal person? And after I set up my goal, I need to do the hypothesis. You could set up the different hypotheses. My hypothesis will be people with larger brains tend to have a higher IQ score. So everyone can have a different hypothesis. You could set it up like people with smaller brains tend to have lower IQ scores. Okay, so this is the hypothesis. I set it up. So now I do have the data and I want to use the hypothesis testing to prove it. And then I'm going to draw my conclusion to see if my conclusion is going to be agree of this hypothesis or I want to reject this hypothesis. So this is the first part of the contest. Second one is going to be the source of the data. Sometimes when you get the data from someone or from some business, you have to be careful. Are the data from a source with a special interest so that there is a pressure to obtain results that are favorable to the source? For example, shoes company sponsored a university to do a survey. Scuffed shoes was the most common reason for a male job seeker's failure to make a good first impressions. So the shoes companies may come to you guys and ask you guys to do the survey. And they already provide you the result and some questions. And what do they want? The company try to get the favorable result can somehow profit from the results. And this is the second part, the source of the data. Number 3, sampling method. Were the data collected in a way that is unbiased or biased? A voluntary response sample. Or you could call this as a self-selected sample. It's one in which the respondents themselves decide whether to be included. For example, internet posts. When you guys go on the internet, you have the experience that there's a window pops up and then say, If you fill in the survey, you're gonna get $100 Walmart gift card. Some people may say, hey, don't bother me, just close the window and goes away. And some people may think, oh, this is really good deal. I just fill in the survey and I got $100 gift card. So we call this is voluntary response sample because you are the one who decide whether to respond. Okay, you have the choice. You're gonna decide whether to respond or not. Second example, mail-in post. Sometimes you may receive some survey and they say if you reply the survey, you have a chance to win $1,000 of the Amazon gift card. So some people may reply it and some people may not. So again, this is the voluntary response sample. You are the one who decide whether to reply. Another example, telephone call-in post. So when you guys watch the TVs, sometimes they ask you guys to call in to register your opinions. So this is also the voluntary response sample. We say this kind of the data, this is the biased one. Okay, this is the biased data because you are the one who decide want to reply or not. And if we have the chance, we don't want to go for the voluntary response samples. Okay, this is the first part to prepare. Second part, that will be the analysis. So we need to know after we collect the data, we want to use the graph to represent our data. And then we're going to do the analysis of the graphing. So on the chapter 2, we're going to talk about the 9 different graphs. And in chapter 3, we're going to discuss important statistics. The statistics talking about like the mean, median, mode, standard deviation or variance. Okay, conclusion. The first conclusion, we could say this is the statistical significance. When we get a result that is very unlikely occur by chance. So again, highlight this one, unlikely to occur by chance. If the event is unlikely to occur by chance, we call this is a statistical significance. For example, getting 55 blue cars in a 60 cars. Think about it. Is this event, is it unlikely to occur? Yes, right? 60 cars and I have 55 blue cars in it. So this is unlikely to occur by chance. So we say the event is statistical significance because this is really extreme result. Okay, example number 2. Getting 10 girls in 45 students. So think about it, if we have a class here, we have a 45 students, is it easy to get 10 girls? Yes, right? This is unlikely to occur by chance. So this is not statistical significance because the event could easily occur with random chance. Okay? Memorize definition of statistical significance. Very unlikely to occur by chance, and most likely we could say like 5%. Everything less than 5%, we call this is unlikely to occur. So this is the first conclusion, statistical significance. Okay, second one, practical significance. It is possible that some treatment or finding is effective, but common sense may suggest that the treatment or finding does not make enough of a difference to justify its use or to be practical. So you could put here, this is the requirement for the number 1. The treatment or finding is effective, okay? It has to be effective. This is the first requirement. And then you're going to think about it. Common sense may suggest that the treatment or finding does not make enough of difference to justify or use or to be practical. Okay, let me use the example here to explain what is the meaning of practical significance. Okay, for example, there's a guy come to me, say, hey, you want to improve your fuel efficiency of your car? And I say, of course, why not? I want to save more money. And then he introduced the X ingredient. He say, if you put the X ingredient into your car, it's gonna improve the fuel efficiency. And I don't really trust this guy. So what I gonna do? I gonna set up my experiment. Okay, let's say this is gonna be my car. Okay, so I'm gonna do my experiment. I'm gonna drive Wolf in the morning at 6 a.m. and I'm gonna drive like 400 miles. And I find it out I only need 14 gallons of the gas. Okay, 14 gallons. And then I'm gonna ask this guy, hey, can you give me the X ingredient? I will just try a little bit to see if it could improve the fuel efficiency. And then the guy say, oh, okay, just try it. And then he give me the X ingredient. So what I gonna do? Okay, this is gonna be the X ingredient. And then I'm gonna put it to my car. And then after I put the X ingredient to my car, I drive to the same road with the 400 miles. Okay, the same time, same road, same car. And I find it out I only need to use 5 gallons of gas. And I say, wow, it really works, right? The same car, same road, the same mileage. I only use 5 gallons of gas instead of 14 gallons. So means the X ingredient, this is really effective. Okay, this is really good. And I say, and I go back to the guy, hey, this is really cool though. How much is it? And then the guy tell me, this X ingredient costs you $1,000. And it only good for a week. Means every week I need to buy the X ingredient. It cost me $1,000. So think about it. Do you guys want to use it? You guys want to buy this X ingredient? No, right? Because $1,000. I only save like about 9 gallons of gas for 400 miles. And this X ingredient spent me like $1,000 and only for a week. So in this result, we call this is not practical significance. Okay, not practical significance. Okay, because one more time, the finding is effective. It fulfilled the first requirement. Okay, finding is effective, but the second one, this is not practical because that's too much of $1,000. And then a month later, okay, 1 month later, the guys come to me and say, hey, we are on the special. It's only $20 for the X ingredient and it's good for a week again. So what do you guys think? Of course, we want to buy it because I do the experiment already. It saved me 9 gallons of gas for 400 miles. And right now it's only like $20. Again, the finding is effective. It's fulfilled the first requirement. And also, it is practical, right? So if the X ingredients selling like $20 right now, then we could say the conclusion. This is practical significance. Okay, practical significance. Okay, one more time. If they sell $1,000, it's not practical. Then $20, this is practical. Okay, practical significance. So you guys learned two conclusion in here. First one, statistical significance. Okay, unlikely to occur by chance. Second one, practical significance. Make sure the treatment or finding is effective first. And then you're gonna prove it's gonna be practical or not practical. Okay, I want you guys to try on this example. Okay, think about it. If this weight loss program have a statistical significance or have the practical significance. Okay, in a study of weight loss program, 35 subjects lost a mean of 2.7 pounds after 12 months. Method of statistics can be used to show that if this diet has no effect, the likelihood of getting this result is roughly 10 chance in 1,000. Okay, so means you want to join this weight loss program. You do lose 2.7 pounds after a year. And then the last sentence here, highlight this one, is roughly 10 chance in 1,000. That means if I didn't join this program and I want to lose like 2.7 pounds, it's gonna be 10 chance in 1,000, so it's gonna be 10 over 1,000, which is gonna be 0.01 and 1%, right? So meaning that this is gonna be less than 5%. So think about it. Does the weight loss program have a statistical significance? Remember this definition, this is very unlikely to occur by chance. And 1%, means very unlikely occur by chance. So we say yes, because the result unlikely occur by chance. How about the second one? Is there practical significance? Think about it. If I want to join this weight loss program, let's say I'm 200 pounds, okay? I'm 200 pounds. And I need to spend a year. 1 year, I only lost like 2.7 pounds. Like, I need to spend like 10 years. I only lost like 27 pounds. Right? So does it practical? No, right? The treatment is effective. Okay, the treatment is effective because this is 1% only. But it's not practical. Okay, potential pitfalls. So when you guys conduct the research doing the hypothesis testing, this is something you guys need to pay attention. First one, misleading conclusion. When forming a conclusion, we should carefully to avoid making statements not justified by the statistical analysis. For example, number of the cigarette smoke and the pulse rate. Okay, if I have a two variables, cigarette smoke and the pulse rate, that is a correlation or association between two variables. Means these two variables are related to each other. Okay, but when you draw the conclusion, you can say that number of the cigarette smoke cause a person pulse rate to change. Okay, when you use the cause a pulse rate to change, this is called misleading conclusion. Because correlation does not imply causation. Okay, correlation, it just means they are related to each other, but it doesn't mean one thing to cause and other things to happen. Okay, correlation does not imply causation. Report result. Take measurements by yourself instead of asking subjects to report their measurements. For example, if you guys come to me and say, hey, how heavy are you? I may just say I'm 90 pounds, but actually I have 160 pounds already because I don't want to let you guys know I'm fat, I'm so heavy, right? So when you guys want to get like those measurements, it's better you do it by yourself. You could just put the weight in front of me and say, hey, close your eyes and step on it, and then look at how heavy I am. Number 3, small samples. Conclusions should not be based on the samples that are far too small. For example, if I have 100 students, can I only ask 3 students their opinion about this class? Can these 3 students represent 100 students on it? No, right? Small samples. Usually we want to take about like 30 or 35 samples or above, okay? It also depends on your population, how large of your population. Okay, number 4, load question. A question which contains an unjustified assumption. We call this as the leading questions. Okay, I want you guys answer my question, and you only can say yes or no. Okay, only yes or no. Okay, you guys ready? Have you stopped beating your wife? You only can say yes or no. You will say, how can I answer this question? Right? Because whether the respondent answer yes or no, he will admit to having a wife. So this is the assumption. I assume you're married, you have a wife, and haven't beaten her at some time in the past. Okay, no matter you answer yes or no, that's some assumption with these questions. And we call this is the no question, okay, the leading question. Okay, number 5, order of question. Survey questions is unintentionally loaded by such factors as the order of items being considered. So for example, could you say that traffic contributes more or less to air pollution than industry? Okay, if I put it on my survey, I put it like this way. And some other survey, I would say, could you say that the industry contributes more or less to the air pollution than traffic? So think about it. This is exactly the same questions. Both questions are compared with the traffic and the industry, right? They just have a different order. But if you put this question on the survey, 45% of the people ban on the traffic and then 27% ban on the industry because they see the traffic first. If you switch the order, the industry and traffic, only 24% ban on traffic and 57% ban on the industry. So you guys can see this is exactly the same questions, but you're gonna get the different answer because of the order of questions. So when you guys construct a survey question, try not to compare with it or try not to put the order of the questions. Number 6, non-response. Someone refuses to respond to a survey questions. Okay, we talked about this guy already, right? Someone refuses to respond to a survey question, just like the voluntary response sample. Okay, voluntary response sample. 7, missing data. Results can sometimes be dramatically affected by the missing data. Example, people with no incomes to be less likely to report their incomes. So if you don't have this part of the data, like people with high income to report the data, then it's gonna be dramatically affect the result. Precise number, one up and one down. So for example, we do have like this number of adults, but generally we're gonna only say 240 million. Number 9, percentage, misleading or unclear percentage. So 100% of some quantity is all of it. You can't exceed 100%. Such references are often not justified. Let me give you guys an example. Okay, for example, I have 200 students. Okay, 200 students for me in this semester. And then I try to give up the survey. Okay, I give 200 survey to the students and everyone turn it back to me. And I want to know, think about it. What is a 50% of my survey? How many number of the survey is like 50% of 200? You could do the math here. 50% of the 200, that means it's going to be 100. So I have a 100 students or 100 survey, right? 100 student survey. Okay, how about if I say 300? 300%. How many student survey do I have? 300%, that means I have 600 student survey. Okay, from math, if I'm doing my math, I'm good. 300% times 200 and I got 600 student survey. But think about it, does it make sense? I only have a 200 students. How can I get back like 600 student survey? Right? It doesn't make sense. Even though they say 300% of the survey, it only means the 200. Okay, it only means like the 200. Okay, this is what they say. 100% of some quantity is all of it, can't exceed 100%. And we call this as a misleading percentage. If you guys pay attention for the advertisement, sometimes they will say more than 300% of the people think that this is good. Okay, what's the meaning of 300%? 300% is not exist. 100% is all about it already. We call this as misleading percentage. And then this is some math in your algebra class. If you don't remember how to do it, you may want to review by yourself. You need to know how to do 5% of 1,400 response, multiply it and get the answer. Or you need to know how to do the fraction, change the percentage, decimal to the percentage, or percentage to the decimal. Okay, that's it for the session 1.1.